Hey guys, this is Michelle Kittner from the Gulfport School District, and in today's video we're going to be talking about complex fractions. By the end of this video, you should be able to find the unit rate of a ratio that uses complex fractions. Now there's some terms in there that we need to go over. We need to go over again what a unit rate is. You went over it in 6th grade, but it's good to review, and we're going to be using it again, so it's good to know. And then complex fraction, that's new. So let's look at those vocabulary words. Remember, a unit rate is just a rate in which the first quantity is compared to 1 unit of the second quantity. So things that are unit rates are like miles per hour. So if somebody is driving 70 miles per hour, they're driving 70 for every 1 hour. 50 cents per apple, it costs 50 cents for 1 apple. So the first rate compared to the first quantity compared to 1 of the second quantity. A complex fraction is a fraction where either the numerator is also a fraction, the denominator is a fraction, or both the numerator and the denominator are fractions. Complex fractions are fractions that contain fractions. But let's review unit rate really quick. Jenny can drive 110 miles in 2 hours. What is her unit rate? What's her miles per hour? So we know that we're going to want miles to hours, because we want this second one to be 1 hour eventually. So our ratio to start is 110 to 2. Remember, we can write ratios that look like fractions. So we can write 110 to 2. And the point of a unit rate is to find an equivalent ratio or equivalent fraction that has the second number as 1. And we can use multiplication and division to find equivalent fractions. What do we do here? We divide it by 2. Whatever we do to one number in a ratio, we do to the second number. So we divide that by 2 to get 55. And this tells us that the ratio is 55 to 1, or 55 miles per hour. Jenny can drive 55 miles per hour. Okay, let's look at complex fractions. They're just fractions that contain fractions. So you can see in this first example, we have the numerator is a fraction while the denominator is a whole number. In the second example, the numerator is a whole number and the denominator is a fraction. And then in the third example, both the numerator and the denominator are fractions. Let's look at a way to simplify this. I don't like fractions inside of fractions. So we just need to remember that fractions are just another way to write division. If we had 2/3, we could just rewrite that as 2 divided by 3. Fractions are just division. So let's take these examples and rewrite them as division. So we have 4/5 divided by 8, and I'm going to change that to an improper fraction by putting it over 1. Just because when I'm dividing fractions, I want them all to be fractions. In the second example, it would be 3, again, over 1, divided by 1/4. And then in the third example, we would have 2/3 divided by 1/4. Okay, that's all it is. Complex fractions are just another way to write dividing with fractions. Let's go ahead and divide these out just for a quick review. Remember, when we divide by a fraction, we take the first fraction and multiply by the reciprocal of the second fraction. So 4/5 times 1/8. 4 times 4 is 4. 5 times 8 is 40. And we can reduce both of those by 4 to get 1/10. All right, multiply the first fraction here in the second example times the reciprocal of the second fraction. 3/1 times 4/1. 4 times 3 is 12. 1 times 1 is 1. 12. And here in the third example, multiply the first fraction, 2/3, times the reciprocal of the second fraction, 4/1. 2 times 4 is 8. 3 times 1 is 3. And that reduces to 2 2/3. Right, so fractions are just division. So complex fractions are just division with fractions. If Antonio can ride his bike 20 miles in 2/5 of an hour, what is his speed in miles per hour? Well, let's look at this visually. Instead of just using math right away, let's look at this visually. Let's break it down. So we want to know miles to hours. Well, here's our ratio, miles to hours. And we want to know how many miles he can go in 1 hour. Well, this tells us that at 2/5 hours, he can go 20 miles. So I broke this double number line up into fifths. We have 1/5, 2/5, 3/5, 4/5, and then 1 whole would be 5/5. So at 2/5, he can go 20 miles. Well, now we basically have a ratio table that we just wrote as a double number line. So how do we get from 2/5 to 1/5? We divided by 2, or we took half of it, right? So we take half of this, or half of the 20, and divide it by 2 to get 10. So that means for every 1/5 of an hour, he rode 10 miles. So at 2/5, he rode 20. At 3/5, he rode 30. At 4/5, he rode 40. And then at a whole, or at 5/5, he would have ridden 50 miles per hour. Miles per hour, he was 50 miles to 1 hour. Okay. Now that we've seen that, we're going to look at it as using the math. We're going to look at it so that we don't have to draw that double number line every time. Because what if the numbers get big or the fractions get big? We don't want to always have to draw a double number line. So here's the steps to finding unit rate in a complex fraction. We want to ask ourselves, is the ratio in the right order? We want to write the ratio as a complex fraction, change the complex fraction to division, and then divide the fraction. So let's look at that. Rather than just try and understand those steps as words, let's look at it. Same example. Antonio can ride his bike 20 miles in 2/5 hours. What is his speed in miles per hour? So here, we know we want miles to hours. Because we want to know how many in 1 hour. So our original ratio is 20 miles to 2/5 hours. Okay, that's step 1. Step 2, write the ratio as a complex fraction. So we have 20 over 2/5. Okay. Step 3, change the complex fraction to division. So we have 20. Let's make that an improper fraction by putting it over 1, divided by 2/5. Now we simply divide the fraction. Multiply the first fraction times the reciprocal of the second. 20 times 5 is 100. 1 times 2 is 2. Now we want to reduce that because we want to find miles per hour. We don't want to say he drove 100 halves miles per hour. Nobody talks like that. So we want to reduce this. We can divide both of these by 2. 100 divided by 2 is 50. 2 divided by 2 is 1. He drove 50. So he rode his bike 50 miles per hour. Maybe this is a motorcycle, because if he's riding his bicycle 50 miles per hour, that boy is cooking. Let's look at another example. Sarah's recipe calls for 1.5 bags of chocolate chips to make 45 cookies. John wants to make 30 cookies. How many bags of chocolate chips does he need? Okay, I want to find the unit rate of cookies to bags. If I can find that, then I can figure out how many bags he needs for any amount of cookies. So I want to find the unit rate of cookies to bags. Okay, and in my original ratio, so is my ratio in the right order? I want to find cookies to bags. Okay, so I want 45 originally to 1.5. Okay, right order, let's see, write the ratio in a complex fraction. So that's step 1. Step 2 here would be 45 over 1.5. Change the complex fraction to a division problem. So step 3, we have 45 divided by 1.5. Now, if we're going to divide this, step 4, the first thing we have to do is change everything to improper fractions. We can't divide by mixed numbers, and we can't divide whole numbers by fractions without first changing them to improper fractions. So let's go. 45 is the same as 45 over 1, and 1.5 is the same as 3 halves. So I'll multiply the first fraction times the reciprocal of the second, 2/3. 45 times 2 is 90. 1 times 3 is 3, and that's the same as 30. So he needs 30 cookies to 1 bag of chocolate chips. So that answers our questions. How many bags of chocolate chips does he need for 30 cookies? He needs 1 bag. All right, let's look at another example. It takes Ashley 1/6 of an hour to walk 2.5 blocks. How many blocks could she walk in 1 hour? So our ratio, we want to again go blocks to hours. Why do we want to do blocks to hours? Because we want to know how many blocks she can go in 1 hour. So we want this second, the hours to be 1, and in unit rate, you want your second number to be 1. So our original here is 2.5 blocks to 1/6 of an hour. That's step 1. Step 2, write the ratio as a complex fraction. So we have 2.5 over 1/6. Step 3, let's change that to division. 2.5 divided by 1/6. Move over here again, 4. We're going to divide this. So remember, we can't have mixed numbers when we're dividing fractions. We've got to change them to improper fractions. So this first term becomes 5 halves divided by 1/6 is already, it's not a fraction. It doesn't need to be changed to an improper fraction. It can't be changed to an improper fraction. Divided by 1/6. Multiply the first times the reciprocal of the second. 5 halves times 6 over 1. 5 times 6 is 30. 2 times 1 is 2. 30 over 2, both can be divided by 2. We get 15 over 1. So there we have it. We have 15 blocks to 1 hour. So Ashley can walk 15 blocks in 1 hour. Okay, I hope that helps, and that you can now find unit rate when complex fractions are involved.